Welcome everybody to Robot Builders Night Virtual for October 28th, 2025. Tonight we'll do our usual roundtable with presenters, and then we'll toss it over to open mic. If anyone's got any questions or needs help with something. And as a reminder, the meetings are recorded, both video and audio. So if you don't want to be seen or heard, mute your microphone and turn off your camera. Just a little housekeeping reminder. Robo Columbus is coming up very quickly, about a month away now. Saturday, November 22nd. And that'll take place, I believe, at Steve's property. And if you need to know where it is, you can reach out to the president at DPRG, or I believe Doug as well, secretary at DPRG, I believe, and they'll be able to fill you in on the exact details and locations. For privacy reasons, we don't want to put it out on the internet. That's about it tonight. First up, we have Tom. Tom's going to give us an update on his latest project.
Okay, let me display something here. Share a screen. This one. And that should give you the first page of a presentation. I believe I showed this one 2 or 3 weeks ago. I'm not sure when I put this together. You guys recall seeing this page?
I remember you showing something about a doorbell system, and you had it. We can see the inside of the old doorbell.
Okay, so what I'm going to do is just use that material to refresh our memories as to what I built and what I didn't build. But the most important thing to do first, not sure what this wants to do. The first thing we'll do is you got to hear it. Let me just plug it in here. You can hear that.
No, we did not.
Heard something.
Let me turn it up.
It's very quiet.
Be very, very quiet.
Okay. So
I think I heard something there.
I heard a little squeak, but not very loud.
oh, I am very surprised. It's quite loud here. I wonder why my microphone is not keen on showing it. Anyway, that's about 11 seconds worth of some Tchaikovsky movies, Tchaikovsky symphony, which is my first experimental waveform that I've been working with to try and make this happen. Back to the presentation. I had talked about the fact that I had very old doorbell systems, wanted to do something fancier, wanted to be able to actually play some selections of real music instead of the non-descriptive, hard to identify front and back doorbell chime things that this thing has done for many years poorly. Also, you'll see the photos of an ESP 2866. It's a WeMOS D1 mini clone. I assume you guys can hear me, right?
Yeah.
Yeah, okay. So this is the WeMOS, this is the 8266, which is one of the objectives was to use this. I like to use what I've got. Relative to what we currently have, this isn't much. This is sort of a real entry-level 32-bit processor, but it still has a lot of value. So my effort is to intend to use it and to stick it inside this module, which is one of the old ones I'm cannibalizing, with a second speaker that will sit in this thing, which currently has a couple of solenoid operated chimes in it. Very, very old stuff, very primitive. I can hear some feedback for what it's worth, in case somebody has a microphone on. So I had talked about looking at some choices for analog output. What I ended up doing and what I'm working with is an 8-bit R2R D2A converter connected to an 8-bit shift register, which is fed from the serial peripheral interface on the microcomputer module running at 10 megahertz. That works very, very well. That feeds into a simple integrated circuit audio amplifier and produces the music which you did not hear, but which I can hear. So for the moment, that should be sufficient for moving forward. And I've gotten this functioning after a long, long learning curve, shall we say. Now let's see what's relevant. I originally looked at a number of different music formats to try and figure out what I was going to use. I eventually ended up with...
Oh, thank you, babies.
Do you want those for lunch tomorrow?
That'd be wonderful.
Yeah, let's all have lunch.
Yes.
Yes, I eventually ended up using WAV files. After some experimentation, I'm using 8-bit unipolar WAV files running at 8 kilohertz. So not 16-bit or 44 kilohertz, which is more typical, and they're mono. And I use a tool, an audio workbench tool called Audacity to do the conversions from typical MP3 files down to the files that I want. And then I add a simple header to those files so that when they're available on the little FS flash file system, which runs on the ESP, there's some way of telling which one is which within that file system. That is working quite well, although the tool that you add to the Arduino development environment that I use, which is intended to make it easy to upload files into the little FS file system on board the Wemos D1, does not work. I tried everything and discovered a number of other people with similar problems, so I had to take some time to write my own. So I basically use RealTerm to send the binary file over the serial interface to a program I wrote, which will capture it, check it out, and add it to the little FS file system as a file. A little bit cumbersome, but it works well, and it's something I can control. So that was kind of a surprise. I was hoping I could just upload these files into the file system without any problems. I've used little FS on the MicroPython system on Raspberry Pi Picos, and it works really, really easily from the Thani development environment. It ain't so nice with the Arduino development environment targeting the Wemos D1, the ESP 8266. But I wrote my own code, and that is working acceptably well at this point. So we'll skip the MP3 stuff, skip the MIDI stuff. I had done a lot of research on MIDI files, thinking it might work out, but I'm not going to use them. I ended up with hardware that looks like this. I believe I showed this diagram last time. It has not changed. What I've been working on ever since is getting the software to work to the point where I wanted it to work. In terms of the code execution, this thing, I mean, a doorbell's simple, right? You push a button and it plays some music. And depending which button you push, it plays different music. What could be simpler? Well, when you read up on the little FS file system, you start to worry about whether there's some variable latency in the time required to fetch data from the file system in order to have it available within the execution loop in order to output it at a very steady, fast rate to the D2A converter. If you don't maintain a reasonably fast rate, a fairly steady rate, you don't get reasonable representation of the sound. I was originally working with 16 kilohertz files, which left me about something on the order of about 60 microseconds to get everything done. The little FS system can easily load a byte of data into the code in 10 or 15 microseconds. That's basically just software overhead in the file system, but it's variable. There's a number of things that cause it to change. So I spent a lot of time putting together and testing various buffers. I built double buffering with various capacities. I built a circular buffer. I tried brute force. I loaded as much of the music file as I could into one enormous array and then played it all from the array. The largest array that you can put using the Arduino development environment on an ESP 8266 is about 50 kbytes. So that tended to limit how long the music could play for, which is when I started to experiment with slower music rates, got the music rate down to 8 kilohertz, and it actually sounds quite nice, and it provides more room to more time in order to execute the necessary code in this very tight loop. I'm running a timer that which is an interrupt response routine to get the very steady output rate through the shift register out to the D2A converter. I had no end of problems with the interaction between the code that was in the service routine and the code that was not in it, and the double buffering. And I would get various lengths of execution, and then I would get a crash, and I would get a crash dump. So I had to spend some time learning what the heck is inside the crash dumps that you get from the ESP 8266. There are tools to decode them. You can eventually get those tools to work and understand what they say. The problem is when you're dealing with crash dumps that are a result of interaction between interrupts and other code, and everything is running very, very fast, and it never stops to do anything. And you get crashes between stacks and between heaps. It doesn't really matter what line of C code you crashed on. It doesn't help you solve the problem. The solution was to remove everything I could out of the interrupt service routine. And by that time, I had also converted the buffering I was using down to a single byte data buffer. And son of a gun, that works perfect. So I'm leaving it alone. I think the combination of running at a slower pace and simplifying the interrupt service routine, which only sets a flag now, that's all it does. And then executing just a single data byte buffer between pulling data out of the flash file system and sending it out through the shift register when it's time to send it out. It seems to work well, and it means there's no limit on how long the music is, other than the file size inside the flash system, the file system. So that's the point it's at this stage, and I'm reasonably happy with it. I'm now adding the logic to do things like determine which push button was pushed, and a little more sophistication, since I can now store 10 or 15 different music selections, some logic that allows me to use the doorbell push buttons and a few other push buttons to select amongst a variety of music segments to play with each doorbell. So I'm making headway. I'm pleased that it's working out well. It's too bad you couldn't fully appreciate the music I'm making. However, that's life. Any questions?
Which symphony is it?
Oh, the sample I'm using is Tchaikovsky Piano Concerto number 1, I think, if I remember correctly.
Very nice.
Well, it is. I've asked my wife to select the music she wants. I don't want to seem biased with my choices, but so far she's offered a couple of choices. I haven't implemented them yet, so we'll see where it goes.
So are you going to incorporate like what would you call that? Individual, recognizing individual people and then having a specific, whatever ringtone or.
Yeah, we can add the camera and the fingerprint sensor and all that stuff later. Right?
Yeah.
Yeah,
The
how
Jaws
does
theme.
recognize a salesperson?
It's actually interesting. The CSP 8266, although it's Wi-Fi capable, it only has one CPU. So the minute you enable the Wi-Fi logic, of course, all the rest of it is going to break. So I haven't even considered the possibility of implementing some form of Wi-Fi access to this thing.
Interesting. I wonder if your sound problem is because your microphone has maybe noise canceling and it's not in the audio range, in the vocal range.
Oh, yeah, that's a possibility, I guess. Although an 8 kilohertz output rate suggests that the upper end of the frequency I'm able to produce is probably no more than 4 or 5 kilohertz, if that. So I'd be surprised the microphone would have a problem with that. There must be something fancier with the Logitech mic that's built into the Logitech camera I'm using, the USB camera. I don't know what it is. I can try it again.
Those have-
It'll work again.
Some of those have pretty directional kinds of things, like the microphone array on my laptop will only pick up me sitting in front of it. It won't pick up any sounds to the side. It does a great job of that.
You can also turn off the noise canceling in the microphone settings.
Yeah, I'm not sure why noise canceling would be the problem. I mean, this source of noise is coming from the same place as my voice comes from. So I don't know what there is to cancel.
Yeah, that's just my thought. Why we couldn't hear it, possibly.
Yeah. Anyway, it sounds great on my end. It sounds better than I expected to get from a simple 8-bit D2A with some very simple low-pass filtering on the output.
Thank you, Tom.
Well, for what it's worth, anybody who wants to know a bit more about the intricate workings of interrupts on ESP 8266s, let me know. I'll stop sharing here.
Okay, well, next up we have Matthew.
All right, I will share my screen. Let's see. Okay, so I joined the meeting about 2 weeks ago. Oh, wait, I'm not sharing my screen.
You are.
Okay, yeah, cool. All right. Yeah, so I joined the meeting about 2 weeks ago, and I talked a bit about my a micro mouse project.
Oh, yes.
For those that haven't seen it, they are basically high-speed maze-solving robots. And I pictured a couple of examples here on the left. And as of Saturday, I just ordered the PCB that you see here on the right. I'm expecting my motors to arrive about the second week of November. So I'll have my PCB in a couple of weeks. I'll have the motors a couple weeks after that. So I have my software in a pretty good state. I'm at the point where it's about time to start doing some hardware tests. That this version of the bot is not meant to be super competitive. The most competitive ones around have these fans that suck it down to the ground for more traction. I don't have any of that right now. I'm just trying to get my foot in the door. So the intent here is to compete at the competition in March. So I don't have too much to share. So if people have some questions, be happy to take them. But yeah,
I'm curious, Matthew. What kind of motors are you using on it?
I'm using two unbrushed motors. I can pull them up if you're interested in seeing them.
Sure.
They weren't cheap, but these have built-in encoders on the back of them, and they're very small. So with the encoders, they're about 19 millimeters long and 17 millimeters wide. So very small motors. On the PCB on the screen is only about 7 centimeters at its widest point. So, not too much larger than a credit card.
Okay.
So
And
no,
your wheels are direct drive on the motor?
So they're going to be geared.
Okay.
They have a couple of examples online that you can look at. You see on this guy here how he has the gear in the center, and then he's got these two wheels on each side. On mine, since I don't have the downforce fan, it's not going to be competitive anyway. I decided to just use 2 wheels as opposed to 4. I'm not trying to go super fast yet. After I compete in 2026, I'm gonna build one that has a downforce fan, and we'll see how well that goes.
Okay. The circuit boards here, the PCBs you had made, are you getting them populated by the fab house?
No, I'm doing it all myself. I have a couple of gadgets. I don't have a way to show it right now, but so yeah, there's actually a bit of a story here. I made a different rather than this circuit board like in January, and it did not go well. I did not know how to solder SMD components, and I had tons of bridging. So I took a step back. I did a ton of researching on soldering these small parts, and I realized I made a few critical mistakes. The first being the solder paste layer. So if you zoom into the pads, and I'll turn on the paste layer here, you can see the gray box is where the solder paste is. On the first revision of this board, this was much larger. I think I can actually change it in real time, and you'll be able to see what I did. It probably looked more like that. And the reason that was problematic is when you're trying to hand place these parts, it's very easy to smear that paste around. So I had tons of bridging, especially on the microcontroller and a couple of the motor drivers. So I didn't even bother trying to power up on the board because it was such a mess. So that was the first thing I changed. I put a lot less paste on the pads, and then I built this gadget. Do I have a picture of it? I might. Hold on one second.
So did you have some sort of silk screen to apply or
Yeah, I've got
like
a
an etch
stencil.
plate? Say that
Yeah,
again?
yeah, I've got a stencil.
Oh,
So
okay.
yeah, the stencil has it's like a laser cut piece of stainless steel that has the paste pattern on it, and then you just squeegee the solder on top of that.
Yeah.
I'm trying to find a picture of this gadget that I made. I used a couple pieces of aluminum extrusion, and yeah, I don't have it on my computer, but I'll find a picture for next time. But it's a piece of yes, 3 pieces of aluminum extrusion, and then I attached a very fine blunt tipped syringe needle to it. And then I have a vacuum pump that's connected to that. So I can move this thing around on my desk and then lower the needle down until it's right on top of the pad, and then turn off the vacuum pump, and then it drops the part onto the paste. And it works very, very well. It's like a manual pick and place machine. So that's how I place these on these super small components without them smearing around anymore.
So you can do like X, Y, and rotation of the part then, or?
Yeah, I think I have a picture. Hold on. I'm surfing my phone right now. I think I sent it to someone.
You can take pictures while you're assembling this board. That would be great to show and present to everybody.
Yeah, I was thinking about it actually. Kind of like making a video of it. I think that would be fun.
Oh, I think it would be fantastic.
It'd be a good thing to practice my editing skills. I think that could be cool.
So did you modify a toaster oven to melt the solder and all that, or?
No, I just have a hot plate.
Oh, okay.
Okay, I found the picture. I'm gonna pull it up on the screen now. Okay.
How do you register the mask on the printed circuit board? Is there like a stud or something that it slips over and lines everything up, or?
I tape everything down to a granite countertop, so it's super flat, super solid. And then I think I just try to line up the holes the best I can. It's not perfect, but it works well enough for one-offs. If I were doing a lot of them, yeah, you can have some some studs or screw holes on there, but I didn't bother with that. But yeah, so on the left side of the screen here, this is the contraption I'm talking about. You can see the blunt tip syringe. I actually have two of these tips. This is the thicker one. I have one that's like extremely fine. It's like it's extremely flexible. You can barely even see it. It's like hair, but you can use that for the small capacitors and resistors. But this whole rig moves around, and you can control exactly where it's going to be.
So it moves around like an XY axis type thing and XYZ.
Okay. So it's just so there was an attempt to add a Z. You can kind of see on this picture, I had this idea to use a screw to go up and down, and I 3D printed this structure here, but there was way too much slop. So I did something else. I haven't added this yet. Let's see. I bought this thing called, I think it was an optical linear range. It wasn't. I'm trying to find the link to it. So I'm going to replace that with, it's like a very small handheld version of this. I've got it at my desk. It's about 1 inch by 1 inch, and it has about 1 centimeter of travel. And this is used for very small, like laser experiments. So they need very fine control over the linear position. So I'm going to replace my very sloppy attempt with this very precise product, and that should solve the Z. But as for the X and Y, I'm just going to leave it as it is right now. It actually slides around very smoothly on the ESD mat. It has the perfect amount of resistance, and I don't have a problem with the X and Y. It's just the Z is a bit challenging without having the manual height adjust.
You have to load the parts manually onto there?
Yep. I'm about to share a video actually. If I can get it sent to my computer here. Okay, let me share this one. I'll create a better video of this because I think it's pretty cool. I think it's even cooler than the robot sometimes. Okay, so this is a video of a test board I did. So it's holding the resistor, and then I turn off the vacuum pump, and it just drops on top of the board. Here, I'll play it again. So yeah.
Interesting.
So you've got to align each component at some pickup location and then picks it up, brings it over, drops it off. And whatever orientation it had, you know, as far as rotation, I guess you don't have any control over that.
Right. So I have to manually pick everything up and then drop it onto the pad. I can kind of rotate the part, with some tweezers or something, and get it roughly in the right spot. But yeah, the process is manual. It's just not worth buying a pick and place machine or having them do it because it's just such low volume. I'm just doing 1 or 2 of them. It would cost quite a bit to have them do it.
Matthew, as I understand it, there are no motors or automated mechanisms on your pick and place rig. Is that correct?
That's correct.
All right.
Yeah, the only motor
only-
is the vacuum pump that's
Right.
holding the part on the syringe tip.
So you move it completely by hand in all dimensions.
Correct.
Got it. It's a
Okay,
nice
it was
it's a nice idea because trying to position those things freehand must be a really difficult proposition.
Yeah, I thought I could. I've got a microscope, but I mean, these components have a pitch of, like 0.5 millimeter. It's just, if you smear it, there's a very high chance that you're going to have solder bridging, and then good luck fixing that, especially on a QFN package where you can't even see the leads.
Matthew, I take it you send your boards out to get them made. Is that correct?
That's correct. I had these made at Osh Park.
Got it. Okay.
Yeah.
Because
So-
if you didn't, I wanted to know how you did the gold plating.
No, I'm not so hardcore that I do the PCBs myself, but I know some people do.
I haven't done a ton of this. I've done a little bit, and I had problems with bridging and stuff too. And how much flux do you use?
Well, on this, I'm using a hot plate and solder paste, so I don't really use any.
Okay, well, here's what I found. I'm using a hot air gun,
Mhm.
and I literally just smothered. You just got a little spatula it all. Made sure my my stuff was fresh. My solder paste was fresh, and just literally slathered across those 1 pins like that chip you're seeing there.
Mhm.
Slathered it right across there, and made sure I had plenty of flux on the thing. Hit it with the hot air for a little bit till it got molten. It all sucked into the pads. I dropped my chip on top of it and hit it with that, and it just sucked it down. Physics helped me a lot. That's how I did it. Your mileage may vary on that, but
Yeah, that's one way to do it. I have a hot air gun, but I use it in certain cases. On this one, I didn't just because, I wanted to experiment with the hot plate.
Oh, I get it. Trying the thing, see which works
Mhm.
better. That's exactly what you should be doing.
Carol, Harold, did you get a lot of tombstoning where the parts
Nope,
stood on end?
not a lot of it. I got some that didn't line up right because it snapped the wrong way. It snapped at a 90 degree to where it should have snapped, right?
Oh,
But
yeah.
it was easy enough to heat that stuff up with my little tweezer and poke it around, and away we went. Of course, I was magnified up 9 ways to Sunday so my old eyes could see it.
Mhm.
And I'm still not very good at it. I've only done a few of those things, but I got
Mhm.
some more to do. Yeah, I watched this cat named Mr. Solderfix on YouTube. And that's what his name is. MR Solderfix. He's a
Mhm.
British sounding sort of fellow. Hell, he could be Australian. I don't know. I can't tell the difference. But he gets up there and he does all kinds of many, many wonderful soldering things. And like, no way he's going to do that. And he explains what he did and he does it. And I'm like, holy crap. Like, for instance, like if you needed to remove one of those parts, my intuition says get your solder wick out there and wick it out and go. What he does, he puts more solder on the thing and then heats the whole thing up so it heats all of them at the same time and lifts the part off.
Mhm.
It does.
He's pretty magical.
Yeah, he is pretty magical, man. He's pretty magical. And I've tried. And one of the tips that I got from him that I use is another thing that you need to have flux just hanging around in is your solder wick. You don't use your solder wick to just dry off. You use your solder wick. You dump it in the flux.
Mhm.
And put the solder wick all fluxed up on top of the pad you want to. Hit it with your iron on the other side, and magic happens. Magic happens. I'm like, oh, I've been doing it wrong all these years.
Hmm.
Yeah, he's pretty magical.
So I just pulled out on my webcam, and I can kind of show. I think you can see it. It's kind of hard to get the lighting right, but this is the whole contraption. You can see how they have the very fine tipped point on there. And then I really just move this thing around in order to place the part. And like it works a lot better than you're probably thinking. And then this thing here is the hot plate. It's really small.
We're not seeing any of that, Matthew.
Oh, you're not? Oops.
No,
It's in his live video, but it would be easier to see it if you turned off your presentation.
Okay, sorry. All right, can you see it now?
And somebody can
Oh.
pin him.
Yeah, I'll pin him.
Okay.
Yeah, that's much better.
I'll have to work on my live streaming. This is the first time I've ever live streamed. All right. So here's the contraption that you kind of saw in the picture. I use a couple of scrap pieces of extrusion. That's why this piece is so long here. But here's
As
the
far
very
as notes for your live streaming, try to keep your camera steady, or we're all gonna get sick.
I'm trying to, but it's
Yeah,
it's
I
very-
get it. It's very zoomed in. I get it. Yeah.
yeah, it's not a very wide angle lens, but to place the part, I just moved this thing around, and it's surprisingly easy to get a very precise positioning on it.
That plus very young eyes.
Yeah, that does help too.
So do you
Yeah.
find just like the I don't know what it would be, surface tension, I guess, that it will actually align misaligned parts a little bit?
A little bit.
Yeah.
In the video I showed, I had the integrated circuit. I think that one was slightly misaligned, and it moved it a bit.
Mhm.
But I find that it's just better to get it right the first time. It just seems to work better.
Yeah.
So that's why I went through all this effort to make sure the part gets placed properly.
The area that your hot plate actually heats, is it relatively small in comparison to
Yeah, so this is the hot plate. It's about 5 centimeters by 5 centimeters. And everything on the robot, with the exception of the back motor connectors, so I'll just point it at the screen. Everything that you see there that requires soldering, except for the sensor ports, which are just behind the rectangles, that fits on the hot plate. So I can actually do everything at one time, which is great. Now the parts in the back, that's where the motors connect. Those are outside of the range of the hot plate. So I might just do it in 2 batches, or I might buy a larger hot plate. Haven't decided yet.
Did you try just using a air syringe instead of a vacuum pump?
I did not.
Dealing with such tiny amounts of air and suction there, that you could probably get away with that.
Yeah, I probably
And
could.
just simplify an awful lot.
I think the idea, because I haven't done this yet, but I bought a small foot pedal so I can turn the pump on and off. So the idea is to be able to just use my foot to drop the part, and I suppose I could do that with a syringe too. But that's a good point. But I didn't go that route. I think I decided to over-engineer it.
well, I guess
No,
if
we
the
would never do that.
needle doesn't
None of
completely
us
seal.
ever.
Did you price what it would have cost to have the service assemble the board for you?
To be honest, I just built this in a couple hours and didn't and really look back, because I was trying to move fast, and in order to price it, I would have had to finish the bill of materials and locate the parts and prepare the stuff for the quote. I just built it and got it done. I didn't really think about it that long.
So you assembled that whole board in just a couple of hours?
Not not the one that you're looking at on the screen or the mouse board. I assembled my test board. The test board was on the test board was just the sensor. So the board that you're looking at on the left side of the screen is just the photodiode, the photo emitter, and an op amp, and a couple of passives. I wanted to make sure that my trans impedance amplifier was working correctly before having the full board manufactured. And it doubled as a soldering test round.
That's really cool. That's
Yeah.
I'm looking forward to seeing your progress on this.
Yeah, me too. Hopefully, by the end of November, I'll have something running around. My dad's helping me to build the test maze. He's got a table saw and a bunch of woodworking equipment. So we're gonna get that built probably around Thanksgiving, and I'll be able to start solving real mazes. It's a quarter size maze, so I won't have the full length, but I can't fit a full size maze in here, so I'll have to settle for the quarter size one.
Keep us up to date on your endeavors. Take lots
Yeah.
of pictures as you're building this thing and soldering it up.
Yeah,
I'm sure
I'm
you'll
probably
enjoy it.
gonna make a little video or something, so because people ask about it and I have to explain it every time, so I'd rather have something to just point them to. Just go watch that, and it explains the whole process.
Thank you. That's been incredible.
Of course.
Anyone have any more questions for Matthew? Okay, up next we have Fernando.
Hello.
Hey, Fernando.
Hello. Okay. Let's see. Entire screen. Okay, can y'all see my screen?
Yes.
Okay. So just a quick overview. This is going to be for something for the Iron Rain FTC robotics thing. The goal this season, basically pick up balls, shoot them out into the goals. I'll share videos of what we've done in a little bit. But the current thing that we're doing right now is we have this flywheel. This is actually what it looks like now. It used to look like this. So it's sorry. So these red parts, they're printed out of TPU and they have some flaps. This is just a cage meant to keep it together. This houses a motor. You can see it's direct drive onto this plate here. And then the shell is what connects everything together. Then we made it out of carbon fiber because we wanted it to be lightweight so it could spin up fast. And then just not take too much time to rev back up after launching a ball. Although the carbon fiber might be overkill for this early in the season, but I guess we'll see. And then this addition here, this change to the cage, it used to just be standoffs made out of either plastic or aluminum ones. However, we're thinking of changing to this due to it being really wobbly, which I'll show again in one of the videos in a little bit. This whole geometry might change, but it's there to allow for cooling of the motor because in this second motor shell here, it's just completely in there and it's going to get really hot after a while of just spinning and spinning for like seconds on end, especially when launching the balls. And then we moved over to this after a test platform that we had, which I will show now. So we had this. So it's just made out of MDF that we cut on our CNC. The ball enters, goes out. So this is the big issue here where we have all of this not wobble, I guess, on this specific side of the flywheel, which is what I'm attempting to fix with this extra cage here. However, I'm not sure that's actually going to do much for it. I'm not entirely sure. Probably will help a lot though. And then this is how far it could shoot. So I believe this was close to about 100 feet.
My
from
dog
all the
would
way
love
back
that.
here.
100 feet is what you said. It's not
100 feet, not feet. Sorry, 100 inches. At that, like 90 to 100, and a little bit over 30 inches in height. I can't remember the exact number for that. Yeah, so it shot pretty far, and then here's this. So this is where we're supposed to make it into. We either shoot from over here or from here in the middle, and then. Still need to improve on our aim. So yeah, this version was pretty successful. Just this janky test platform that we made out of MDF and some rev rails or aluminum extrusions. And now we've tried switching over to a design like this. However, that hasn't worked out very well. And then this is pretty much the same thing, with just some minor changes to the design and things here. But what's going on is this is just not launching far enough. I get max 10 inches maybe in length, 10, 20. So it's really not going that far. There's no power. And I mean, there's visibly a lot of the power from the flywheels going into ball spin instead of forward velocity. And then, like I shared a little bit ago, there's still this problem. It's really shaky. Yeah, just been having problems with that since its first conception, and then now with this solo shooter without the whole ramp down here. It just does not have enough power to actually launch the ball. And I'm not sure if there isn't enough traction between the ball and this, as well as these guides here, or if there's just too much and it's not allowing the ball to spin, because it's also a bare motor, so it doesn't have as much power as other motors might have. But we kind of need the bare motor for the speed. So I'm not entirely sure what to do, and I kind of came here to ask for help and to show what we've been working on.
Is there a way to mount a bearing support on the free end
There is actually. Hold on.
to help support it from the wobble?
Oh, on this end. Let me see which end is actually. So, hold on. I'm not used to using Fusion on the desktop. So, this wall has a bearing in here, and then this one. I've tried making finding a bearing that would fit it, but it would have to go like around there, and I just couldn't find a bearing big enough.
Okay.
For this side.
He mentioned that most of the energy, or you mentioned that most of the energy was going into making the wheels spin. What if you used, or the ball spin? Sorry.
Yeah.
What if you use 2 flywheels instead of 1, and then it gripped the ball from both sides, so it shot it out straight without putting torque on one side of the ball.
Okay, so like adding a sort of counter roller around the same speed of this flywheel, like somewhere here.
Yeah, they have these things that they use for throwing baseballs, and they often have 2 wheels. I think.
Could you add a TPU strip on? I don't know what that is. I can't show you on my screen. On either side, where it looks like the ball makes contact with the back of the mechanism, not the flywheel or the other TPU strips.
Mhm.
So it, in other words, as the front two grab it, it actually pushes it against the TPU strip in the back,
Mhm.
and should prevent it from, just spinning the ball and not throwing the ball out.
Okay. I definitely could try that.
Yeah.
Sounds good.
Yeah, like on that surface that you just highlighted, like, yeah, right there. No, right there. Okay.
Or
Yeah, either there or on the side.
okay.
That may work.
Yeah, it definitely sounds like a good idea.
But I imagine Mr. Kareem has all-knowing, all-seeing. He can tell me whether that's a good suggestion or not.
No, that is a good suggestion.
Okay.
The dual shooter designs or the dual flywheels, those are sort of like an entirely different approach to the problem. And so I have two other teams pursuing that approach. The issue there is that because you have two counter-rotating flywheels, right? There's only one instantaneous moment at which they both compress on the ball at the same time, right? And so there's an instantaneous huge amount of acceleration going on, whereas this approach gives you a smoother, gradual acceleration, although that's shortened in this design versus the first ones that you saw, where you had a full, half of a circle to accelerate through, and so they have to be compressed pretty well against the ball in that instantaneous moment where they count, where they both hit it, and your side-to-side accuracy is much more difficult to control because of that really short period of time where they're in contact. But yeah, these are basically the two most pursued approaches is this sort of hooded flywheel shooter solo versus a dual counter-rotating approach. And so this team is doing this kind, but this is like the first iteration where they're taking their initial proof of concept that was going pretty far and trying to make it more on-bot adaptable, right? Because you got to think about the whole path the ball's going to take, not just the final shooting thing.
So do you have to shrink it down to this size to make it fit, or could you go back to the first approach where it was shooting it the way you wanted it to?
So, I mean, we could adapt. We could make the chassis around the original design with the whole ramp. However, the way we're trying to hold it is we can hold 3 balls at a time, and we'd like to hold the balls on the ground vertically. Let me see if I can find a sketch we made. But basically, that would require this to be in the center, and that just can't happen with the big ramp because we're limited to 18 by 18 by 18 inch cube, and then some we can't extend at all inside of that cube. So we wanted to save as much space as possible, which is we're holding balls at the ground, and then they have to go directly up. So we'd have to get rid of that ramp.
There's sort of additional space constraints this year because you'll see that it's a big 5-inch wiffle ball. And they're still constrained to 18-inch cube starting size. This year, they can't even expand out of that except in the very last 20 seconds of the match. So the entire time that they're shooting, they have to have a path that intakes the balls, holds up to 3 of them in a magazine of some sort, and then controllably delivers them to the shooter when they're in the right position for making the shot. So they've got to figure out how to as a space constraint, it makes it very difficult to do what they did with their initial prototype.
No.
What is the servo on the back of the launch unit for?
So this was kind of just my idea at being able to control the angle. Hold on. The angle that the ball actually launches at. I'm not sure if we'll end up going with this, as there are some issues with the design of the rack and pinion, and then I have to work more things out on how to actually constrain this in the center. And then Mr. V had actually offered the approach of just using a flap that we control. So we should definitely experiment between both ones, see which one works, and just see.
What was Dave holding up?
I was holding up a example where I did it manually with a soldering iron. I can show that a little bit larger when it's my turn.
Okay.
I'll put you in after Fernando, Dave.
Okay.
Hey, Fernando, on the, it looks like the red wheel pushes the purple ball against the two supports in the back, I would guess.
Yeah.
And is it that why those two supports in the back kind of have enough friction that it holds that surface of the ball so that the momentum transfers to rotation? So I wonder, what about if you're able to reduce the friction on those curved struts in the back? Like, I wonder if like a lower friction material, if it was just solid, or if even there might be a way to put like kind of to line those with captivated ball bearings or something.
So this is interesting, Carl, because you gave the exact opposite that Ray was suggesting, right? And so which intuition do we think is right? Do we need more friction or less?
More.
So currently with these, I've already experimented 3 different like depths of it to change the compression that the ball has in the system. So, I mean, you would need some kind of compression to make sure that it launches far enough, but maybe some is too much, some is too little. And then currently these are being made, the first ones I made were out of nylon, and now I'm making them out of silk PLA. They should have similar-ish like friction, and it's along the layer line. So the layer lines follow the curve. So it shouldn't have too much friction. So I'm wondering if maybe the compression I'm at is right, but it just needs more friction. So I think I'd test that first, since I've kind of been experimenting with that less friction route already.
I might have missed something.
Yeah,
could
I
you
think
use like a foam wheel?
So can you explain the fins and the construction of the red TPU?
I explain the fins.
The drive wheels, yeah.
Yeah. So
I
the
want to
fins,
zoom in on that too.
oh, actually,
You have the actual unit with you?
I can go run and get it.
That's all right.
Okay. Yeah. So the fins, originally we had much smaller ones. They kind of just acted like little teeth that barely had any friction on the ball. But now these flaps will be compressed whenever going up against the ball, and then some of them might even go into these the wiffles of the wiffle ball, increasing the traction, the friction that it has with the ball, and helping propel it forward. Another reason why we extended the length. Same reason why they're made out of 85A TPU, more flexibility than 95A. But yeah, not sure if I missed something.
Do those hold up that well, or do they break off after, say, 100 balls going through the mechanism or something?
We haven't gone to 100 balls, but I mean,
No?
they've lasted up pretty well. Delamination is an issue or is a concern with the TPU. I think it does happen slightly every time that we run it, but it hasn't exploded on us yet. So, I mean, it's working out.
The TPU is remarkably durable. It's crazy durable. Like, we've been using it for years and years now, the same Ninja Flex stuff, and we've never had a part wear out. And we've done this kind of thing in the past with different forms of shooters. We've built wheels out of them, and that's not the part that's going to fail anywhere near first, and we've never actually seen them fail at all, as long as they were printed well.
I'm interested in the comments you made that with the earlier, simpler looking but larger launch unit, you were getting very substantial distances, much longer than you're getting here. Were the wheels essentially the same, the drive wheels?
Yeah, they were the same flywheel.
They were
We
the
just
same.
transplanted it over.
Have you considered seeing whether you can take a video of the movement of the ball as it goes through the drive wheels to see whether there's any strange behavior happening in terms of slippage or rotation that's hard to see with your eye? Take a video.
Yeah, definitely should do that. We did it for the
Let's
first one.
study it frame by frame.
Slow
Yeah.
motion.
It sounded fairly obvious to me what the problem was. The problem was this one has a much shorter acceleration path. So they're using the same wheel, but it's only in contact for a much shorter distance.
Yeah, it's in
Okay.
contact for about a third or a fourth of the distance of the other one.
So does that mean that you're seeing a significant drop in speed of your drive wheel when the wheel hits it?
Probably, which was another thing. I mean, adding weight would reduce or would increase the momentum and reduce that drop, correct?
If you add inertia, then it may not slow down as much, or add more power to the motor so it'll accelerate faster.
We're already at our limit on motor power because they're driving it straight off of the battery maximum voltage, and they're not allowed to use more powerful motors. And this is already a 1-to-1. It's a direct drive. There's no transmission losses.
Okay.
So they would have to go to an external motor and gear it down for more torque. But then they're going to lose speed, and so they actually did some calculations early on, and this is like the size of the wheel. It also like got to get up to speed fast enough, because at this point, this one is like it takes how long does it take to get up to speed, Fernando?
I'm not sure. It sounds like it's going the same speed. I mean, after a few seconds, but I'm not. It's no scientific process by any means.
This would suggest that when the ball hits the drive wheel, it slows down a lot and never has enough time to get back up to the speed you need to launch the ball far enough. Have you considered a smaller diameter drive wheel?
Yes, however, we haven't gone there, but we probably should try it out.
The other question I had, have you thought of using a drive on the back of the opposite side of the ball, along where your servo gear setup is? If that was a rubber belt to help drive the ball through.
As in have the rubber belt like move, or how? How do you mean?
Yeah, so it could rotate around basically rotate and help propel the ball up and forward.
I kind of wondered, okay, this may sound crazy, like my wife says, get the ball spinning and then stick something on the back of it so it adheres to it and maybe takes that momentum and propels it out of the chute. Maybe it sounds too complicated. I think that like a TPU strip or something sticky on those two rails would work.
I'm sitting here thinking, if you really want it to move fast and far, hit it with a baseball bat.
Yeah.
Yeah, that's
Why are you using
like
a wheel? Hit it with a bat.
if that curved thing in the back could, as the ball comes up towards the top, if it could detect it and then use a solenoid or something to kick the ball out, or even better yet, get Ray's air compressor gun and blow it with a big blast of air.
Small tank, maybe.
Yeah,
Of course, that's going to be
blowing a wiffle
complicated
ball
and
with
get
a
the
blast of
timing
air
right.
is tricky.
Or set a dual TPU motors like that and do like a baseball launcher and just grab both sides of the ball and launch it out.
Yeah, imagine a wiffle ball doesn't have a lot of inertia, though. It's, you know, like if you could transfer that, get the ball spinning and then put something, touch something sticky on the backside, so it does, you know, jump out of the little holder.
So at a couple seconds of acceleration time between balls, is that an issue?
Definitely. Yes, even on the old version. We have video of them, and having 2 balls at a time isn't too bad, but 3 definitely to know. And the timing has to be just right. So you have to have at least like a second or 2 between balls. And I mean, that's on the old version, so I can't imagine what it is on this one.
Yeah, you're power limited and you're space limited, and you don't control the ball. Somebody else supplies the ball design. That's an interesting set of constraints.
And they're trying to shoot from the furthest distance possible. Of course.
That's where the points are, right?
Because you can drive right up to the goal and shoot from like at the base of it. And so there you have to be able to shoot almost straight up. Totally different trajectory.
But yeah, I think that's all. Thank you so much for all the recommendations and then for the questions. I enjoyed talking about this stuff. But yeah, thank you.
Well, thank you for presenting, Fernando. It's always interesting to see what you guys are working on. And as we commented in the pre-meeting, it's amazing what you guys do in, you know, a short amount of time. Some of us are struggling, you know, for months on things, and you guys, you know, are banging out problems in a matter of days or weeks.
And doing it in their spare time.
Yeah. On top of a full-time job. It's Thank you.
Thank you.
Very, very interesting.
Yeah, very interesting.
We all had that kind of energy once.
Maybe a slingshot. Can you shoot a wiffle ball with a slingshot?
You just got to be able to do it fast enough. It's like the scoring system's about how often you can repeat those. There are going to be teams that are going to be doing 60 of those throughout a 2.5 minute match or something like that.
Oh
so that requires short reload time and just totally quick turnaround. So
that's on top of finding the balls.
Yeah, you got to go around, chase the balls down, load them up real fast, turn them towards the goal and shoot them. So they're also talking about a turret so that they can be aiming it separately from where the chassis is going. Right.
Yeah.
So multiple balls are going to be on the ground to gather up, like he said.
There's about 40 balls on the field, something like that the 4 teams are chasing after, and they're of course like running around on the field, and you can only have 3 of them in the robot at a time, or under the robot's control at a time. So,
well, if there's that many balls, should you collect them? Would it make more sense just to go after them in the field?
I'm not sure what the difference is when what you're saying.
Well, if you can collect 3 balls, then you can shoot 3 balls in a row. But if you can there's only certain locations on the field you're allowed to shoot from. Oh, okay. So you've got to go back to that every time.
Yeah. And they're generally not where you're picking the balls up from. There's certain paths that they tend to take based on, like when you shoot them into that goal, they go down on this rail, right? Mm-hmm. And they accumulate there, and then you have to release them, and so a whole bunch of them come out at the same time. And the ones that you earned and you released end up going over towards the enemy side of the field, right? So it's easier for them to get them. And so they designed it so there's going to be a little bit of robot interaction going on this year.
Definitely an interesting challenge.
Yeah.
I look forward to seeing an update on how they managed to solve that issue, because I don't think we give them a little constructive advice, but I don't think we give them anything definite that they can use yet.
Yeah. We'll see how it goes.
Next up, we have Mr. Dave Ackley. He's going to give us a demo on some surface mount devices he's soldered.
Okay.
I'm going to pin you, David.
Oh, yeah. Let's try that.
I got you pinned.
Okay. I don't know if you can see that too well. Clearly.
Right about there, yeah. Well,
Okay.
a little more forward.
All right. Those are all hand soldered parts. Okay. And with ancient eyes and hands. With those resistors right there.
With a soldering iron or with hot air?
Soldering iron.
Yeah, maybe those eyes and hands aren't as old as you think.
Those resistors right there are 603s. This part right there is a SOT 23-6, which I think are about 50 mil spacing on the pins. But those are the resistors and capacitors are larger. They're 804s. I only did 603s there because the spacing was such that between the pins here on a USB-C connector constrained that. But those are hand soldered. And what I did was I went onto the web to see how people did that. And lo and behold, they use a pair of tweezers and they use a soldering iron and they hold the part, for example, the resistor capacitors, they hold the part down on the pad and they touch it with a soldering iron with a little solder on the end of the soldering iron, and bing, it's soldered down. And then you go to the other end and you go bing, and it's soldered down. So you don't have to use fancy masks to do paste or soldering ovens or things like that if you're doing something that's too complicated. Anyhow, that's all I had.
Well, thank you.
Yeah.
I didn't think that that's possible with just the soldering iron like that.
Yes, it is. It's a fine tip soldering iron.
I mean, it wasn't your 240 watt flat blade thing?
No, it's a
Soldering gun?
A weller, with the trigger.
Weller,
The kind of you raised pipe with?
with a very fine tip and a very fine solder. And it's possible. Oh,
I think I would just have a big blob of solder on the chip.
The trick though is to flood the whole thing with flux.
And then wash it off afterwards. Huh?
Exactly. You wash it off afterwards.
Dissolve it, whatever. Yeah. Huh.
But it
Yeah,
is,
I try.
it is possible to do it.
The secret of my success,
Yep.
through hole.
Yeah.
Oh,
I'm
there
with
you
you, Pat.
The way to do it, right?
The parts I was using, the SOT 23s, that was the size of the parts that I had to deal with.
I think some of those 603 resistors would fall through the holes in my board.
Yeah, they probably would.
Nicely done. Good technique.
It was. That's impressive.
Well, like, it wasn't my first try, but like I said, I studied a lot of examples that were on the web of how they did it and followed suit. And yeah, you can do it. In fact, on the web, they actually showed doing 402 parts, but I would not attempt that. The 603s are, I did those because I had to, because of the spacing. But the 804s, not much trouble at all.
Well, here's the opposite of success here. There's a little resistor that either goes to the internal antenna or to a coax connector. And they said all you have to do is, move it from one side to the other, and ripped off traces, and it made a mess. I don't even think this board's functional anymore because there's no pad on the other side of the resistor anymore. So.
Well, I'll admit that some of my boards didn't turn out too good either.
Oh, okay.
But it is possible.
Yep.
I've considered buying a hot air soldering station just, for trying it out and seeing what you can do. Some of the Chinese sites have them on for a decent price. But I've always been leery about it. And as, a number of people have said, my old eyes, I don't know if it could take that. I'd have to magnify right up. But
yeah, I tried using the, one of the hot air stations at the Makerspace, and it doesn't take very long to, these fiberglass epoxy boards to heat up the epoxy too much. The whole board deforms. You definitely have to have a timer because you're going to be focused on, doing something and not realizing, how hot the thing got or how much time it was, under the heat gun. And so, yep, got the parts soldered, but way too hot. It just distorted the board all, it's like made it, like a piece of acrylic or something. Just
so that was everybody on my list. Does anyone else have something that they'd like to present today? We open it up to open mic. Any questions, comments?
The Mr. Solder guy, I didn't catch the name. What was it? The guy that did the videos.
Matthew.
Say that again.
Matthew.
Oh, no. They were
The
talking
Mr. Solder, Mr. Solderfix or something.
something like that. Yeah.
Cut that out. Was that Harold?
I think Harold mentioned it. Yeah.
Was it Harold? Okay, is he still there? Oh yeah, there he is.
Just off.
Harold, can you update us on the solder guy you had mentioned for the video?
Yeah, his name on YouTube is literally Mr. Solderfix. That's MrSolderFix.
Okay,
He's got kind of a British Australian type accent.
good.
Kareem just posted a link.
Channel.
And,
That's his channel.
he does amazing things like as he's going and doing all this stuff, so you can actually see me. As he's going to do is he'll get up there, with he'll do through holes, he'll fix traces, he'll get the SMD things, he'll do all this stuff. And one of the things that just amazes me is, when you have the 3 holes and you need to go clear it out, right? Well, you usually get it out, or you get the solder sucker, you get the wick on it or whatever else, and you usually close over the hole, and then you got to get the hole out of there. If you're watching him, he gets up, I don't know, he's got his board elevated a little bit. As he's soldering on it, the thing just drops out as clean as a whistle. It's truly amazing. He's a miracle worker.
It just dropped out of the hole.
He calls it drops out. That's what he calls it. Drops out. He solders on it, solders on it, solders on it, and whatever he's soldering on, eventually, because it's got gravity, gravity grabs it enough, and it just drops right out, and he's clean. You'd think the holes look 10, but they don't. You'd think they'd never been soldered on when he got done with them. And he just seems to he's magic as far as I'm
Solder whisperer.
Yeah.
The incidentally, the solder that I'm using, I don't know if you can, let's see here.
Is it 10 lead or antimony?
It's 15 mil solder.
Is it flux core?
Let's see, what does it say? Yep, flux core.
Yeah.
And while I got the floor just a little bit, Karim did a heck of a job at the Hackster presenting Hackster the other day, week or so ago. He did a heck of a job. Good job, Karim.
Thank you.
But as I said, I flood everything. I use what they call an acid brush and a bottle of liquid flux, and I just swab it on, and the tip, probably you can't see it here, but it's a pretty fine tip.
Do you only do the pads you're working with, or do you somehow do the whole board or big swashes of it?
Pardon?
Do you just flux up the pad areas you're working on, or do you get a big surface area?
I just flux where I'm soldering.
Hmm.
I put a little blob of flux there, and the circuit board is gold plated, and the components have a little bit of solder on them, you know, the way they come packaged, and I just put a little knob on it, solder it down, and there's a guy a British guy that wears a hat that demonstrates how to do it, and I followed how he was doing it, and it works.
Your tweezers, are they squeezed to open or squeezed to close?
Squeeze to close.
Oh, okay.
Let me, if you'll bear with me, I'll go get a pair.
I thought maybe the squeeze
That's what he was
would
showing in
be
the video.
better, but I don't have a pair of those.
I thought that's what he was showing in the video in his video was tweezers.
Yeah, but they have them, you know, some of them are, you squeeze them to open them. The others are, you know, squeeze it to close it. So I thought maybe the squeeze to open would be better because you don't, you know, have to put tension on it.
Well, here's a pair that I use frequently. It's I don't know whether it's not some sort of.
Can you hold it a little higher, David? Thank you.
It's some sort of plastic that doesn't melt.
Huh.
You know, hold.
Those are squeezed to open.
And these are squeezed open.
Yeah.
I have another pair that's similar to this. That's very fine. I don't know where it's at the moment in my pile of junk. That is very fine, and it's squeezed to hold. And I use that. I'll see if I can find that.
Yeah, mine, I just had the squeeze to close variety.
I have
need to
whatever
get
my
rid of-
wife has in her makeup bag.
What's that?
I use whatever my wife has in her makeup bag.
Oh,
We won't tell her. I can imagine the squeeze to open would be nice because then you can let your hand muscles focus
Yeah.
on orientation.
yep. That's what I would think.
Yeah, but then you got to let them go. And that always, anytime you squeeze one way or the other, right, it's going to jostle your part a little bit. So you're still going to have a fine little push to a line kind of a thing.
I don't know.
Parts
Every
are small.
time I switch between the squeeze to open or squeeze to close thing, I drop the thing about a dozen times before I rewire my brain.
Yeah.
But Do you hold the part with the tweezers while you solder, or do you let it go in the solder paste?
No, I hold it with the tweezers. There's another pair.
Right.
Yeah, so that's what makes me think for David's approach of the
And you hold it in place
while you
and-
solder.
and you solder one end of it, and then you take and solder the other end. And it's doable.
So how many 603 resistors do you have to use to solder one in place? 'Cause I imagine there's a pile on the floor somewhere when they drop.
A few fall on the
Small
floor.
pile.
You definitely want to get about twice as many as you're going to use. But these are special super fine tweezers. Let's see, what is it?
Gonna say maybe you have to have flux with a certain velocity viscosity to make it all work.
Yeah,
That's the problem. I haven't bought the right velocity flux.
That's right. Your
There you go.
velocity is too
well,
slow.
actually, on the flux, what I did was I went and got a old fingernail polish and flushed it out with isopropyl alcohol and got it good and clean, and then poured the liquid flux in there, and that's what I use.
Okay.
So it's got, the little brush for painting your nails, and I use that to daub on where I'm going to solder, and it works.
That's neat. And so you're getting obviously good results doing what you're doing.
It works. Now, I'd say I don't have 100% success, and I have a few board. I get the boards from, or I haven't recently, but I used to get them from China. 5 boards for a crack, $2 a piece, and $1.80 for shipping. And so, if I messed up a board, throw it out and start again, and have enough. I get the parts 100 on a roll, and away I go. So anyhow, that works.
Hey, Kareem, has your security guard robot been put into action yet, or not yet?
It's tasing people left, right, and center.
Oh man, you're on your way then, huh?
Yeah. What was the name of that robot in RoboCop? I'm totally blanking on the name. Anyhow, no, it's still progressing. I'm wallowing in like Docker configuration stuff at the moment. Trying to make it more different of its packages, more usable by external, third parties, that kind of stuff. So not much progress on roaming around outside right now.
I was going to say, if you make it too nice, it's somebody's going to hit it with a baseball bat. But if you,
Yeah.
A little more, what was his name? Arnold Schwarzenegger, maybe, Terminator.
Right. I'm going to try and stick with the nice personality until I find out that it's insufficient. I don't want to be the guy to usher in, Skynet.
Anyone else got something to display, report, show?
Ed 209. All right. I got a bolt. I'll see you guys later.
See you, Cream. I can give a little update. I've been working on This guy, I don't know if I should pin myself maybe. I don't know if I can pin myself.
That do it?
Somebody pin me?
I think I did. Yeah.
Okay. Well, I'm working on my Canbot. With the can, the LiDAR. I got a Raspberry Pi 4 on top. I got a caster underneath. I've got a Raspberry Pi Waveshare RP2040 at the bottom. I just put a power supply in there and I was getting that tested. I've been working on the MicroPython for that RP2040 board. Underneath Mr. LiDAR, I have a hard drive. And there's the LiDAR. There's my hard drive for lack of space of putting it anywhere. It slips just on top, so it covers part of the Raspberry Pi, hopefully leaving enough of the heatsink showing. So, been making a little bit of progress on it. Nothing spectacular, but it's coming along. I'm getting ready to test the motors with the motor driver hat that goes on. And so I have a there it is, a motor driver hat that fits on top of the Raspberry, the Waveshare RP2040 Raspberry Pi board, the Pico board. And on top of that, that's my board I've been soldering. And that's for the encoders. Hard to see. Encoders and a servo coming off of the board. So just getting ready to that in and start spinning some motors and checking the encoders that they're working. And then starting to develop some PID, tune the PID loops for it and make sure we can drive forward. So aside from that, I've been also working with Paul. Paul helped me out last week a little bit with some ROS 2 and getting Docker up and running. So I have that going. After the nice GitHub presentation, the Git presentation we had the last couple meetings, I've got another project up on the GitHub and synced. So now I'm just working on what part of my robot should I be basically pushing up to the to GitHub. So does it need to be the whole thing, the whole ROS folder, or can I just do, maybe a couple in the source folder? So that's, I'm not sure which way to go with that yet. That's what I've been up to. And too much work. Does anyone else have something to present? Okay, well, if there's nothing else to present, I guess we will call it a night.
Sounds good.
Cool. Well, thanks, guys. Good to see you all.
Good to see you too, Carl. How you doing?
Oh, coming along. Yep. Another 3 weeks and maybe wait on the left foot. We'll see.
Ooh. Did you break bones or?
Yes.
Yes. Ooh. Yike. Sounds pretty serious.
It was a big deal.
I'm going to stop recording and we can talk.
Oh, yeah. Sorry. Yeah.